Hydroelectricity is electricity that's generated by kinetic energy of moving water. It is the second most commonly used form of renewable energy in the US and pretty much in the world. So, hydroelectricity accounts for 7% of the electricity that's generated for the United States. And more than one half of the hydroelectricity that is generated is in three states: Washington, California, and Oregon. Worldwide, though, nearly 20% of all electricity comes from these hydroelectric power plants, and China has got the lead on that. Next to China would be Brazil and then Canada, and then behind all of that is the US. So let's look at ways that hydroelectricity is generated, and we'll continue to look at if it's even a sustainable option. There's a couple methods to hydroelectricity. In run of the river hydroelectricity, that is where water is retained behind a low dam and then it runs through a channel before returning to the actual river. Storing water in a reservoir behind a dam is known as water impoundment. And tidal energy, which also comes from the movement of water, although the movement of water in this case is driven by a gravitational pull of the moon, tidal energy systems generate electricity in a similar fashion. Turbines, and they use the river to run system and water impoundment system kind of like all together. And it basically captures the energy of water flowing through estuaries, rivers, and bays. And through this whole system converts that to electricity. It's actually pretty complicated in a sense, and also very interesting. Although tidal power plants are operating in many parts of the world, we really see them in places like France, Korea, and Canada. So tidal energy does not have the potential, though, to become like this major energy source. And in many places, differences in the water levels between high tide and low tide are just not sufficient or high enough to produce a large amount of energy. Mommy. Regardless if it's run of the river or an impoundment or a tidal operating system, all hydroelectric dams work basically the same way. There's a reservoir of some sorts, and then there's an intake where it turns a turbine, and then there's an outflow. And in that whole dam system that houses the actual generator that's hooked up to a powerhouse, that's hooked up to power lines. And so if you look at the diagram here, this in particular is an impoundment dam, and so the arrows indicate the path of water flow on the picture. Major hydroelectric dam projects have brought this renewable energy to large numbers of rural residents in many countries, like the United States, Canada, India, China, Brazil, and even Egypt. Although hydroelectric dams are expensive to build, basically once they're built, they require minimal amount of anything, fossil fuels to even operate. So in general, the benefits of water impoundment in the hydroelectric system are great. They generate large quantities of electricity without creating air pollution. The waste products are really low. There's low CO2 emissions. So electricity from the hydroelectric power plants usually is less expensive for the consumer. And the electricity generated using nuclear fuels or natural gas comparatively, it's also less money. In the U.S., the price of hydroelectric ranges from 5 to 11 cents per kilowatt hour. In addition, the reservoir behind the hydroelectric dam can provide recreation and economic opportunities, as well as, we're controlling the downstream flood control for flood-prone areas. It's just all part of a greater picture here. The AP Environmental Science exam loves to talk about dams. For example, Lake Powell is the reservoir impoundment of a hydroelectric plant in Glen Canyon Dam, draws more than 2.5 million visitors to the Glen Canyon National Recreation Area each year. And that generates more than $400 million annual dollars for the local region, which is in Arizona and partially in Utah. And then in China, the Three Gorges Dam provides flood control and protection to millions of people. water impoundment does have a negative environmental consequence. In order to form this impoundment, a free-flowing river must be held back, and the resulting reservoir may flood hundreds or even thousand hectares of prime agricultural land, or even a canyon, things with great aesthetic beauty and even archaeological value. And it also may force people to relocate. So, the Three Gorges Dam, when it was being built, more than 1.3 million people submerged. It had to relocate 1.3 million people, and it also submerged like ancient cultural and archaeological sites, as well as it basically ruined a bunch of farmland. So, impounding a river in this way may also make it unsuitable for organisms or even some recreational activities, depending upon how free flowing this river is. So, large reservoirs of standing water hold more heat and they contain less oxygen than these free flowing rivers. So, therefore, it affects species that can live there, right? Certain human parasites also become more abundant in these impounded waters when they're located in tropical regions. So, by regulating the water flow and flooding, dams alter the dynamics of the river ecosystem downstream. So some rivers have sandbars that are created during periods of low flow and that flow periods of flooding, and some plant species like the cottonwood trees, they cannot reproduce in the absence of these sandbars. So the life cycle of certain aquatic species like salmon, certainly, and trout and freshwater clams and mussels, they also depend on like seasonal variations in flow in water to survive and reproduce. And so this impoundment system disrupts all of their life cycles. And so by controlling the flow of water, though, we can get a constant, plentiful amount of hydroelectricity. It is possible to address some of these problems, like like fish. We may allow fish to travel upstream in a dam. If you've ever seen the salmon ladders, they're like little ladders that the salmon push their body up against to basically get over the dam to reproduce. And they're fascinating to watch. Another environmental consequence would be house gases to the atmosphere, both during the dam construction and after filling the reservoir. So the production of all this cement is a major component of the dam, and it's basically responsible for 5% of all of the CO2 emissions into the atmosphere, if you believe it. Once the dam's completed, though, the impoundment water usually covers forests and grasslands, and so now we have a bunch of dead plants and organic material into like flooded soil areas, and so now things are decomposing, and this is all anaerobic, and anaerobic metabolism releases a lot of methane, and methane's a very potent greenhouse gas. So some researchers, though, especially like in tropical regions, they say that when methane is released from this process, that the hydroelectric water impoundment contributes to climate change, and that it's worse than a coal-fired power plant that generates the same capacity of electricity. Not to mention that there's an accumulation of sediment in these reservoirs. It also has a negative consequence for the environment and generating electricity. So a fast-moving river carries sediments that settle out when the river feeds into a reservoir. So the accumulation of these sediments at the bottom of the reservoir is known as siltation. So to recap here, we've seen that biomass and water are two important renewable energy sources. And biomass is a modern source of carbon, which is formed between a few years ago and hundreds of years ago, as opposed to fossil fuels, which contain carbon that's formed millions of years ago. Solid biomass includes wood, charcoal, and animal manure, and all of which are relatively low quality sources of energy, and they release a fair amount of particulates and other pollutants when we burn them. Liquid fuels, including ethanol and an alcohol, those are derived from plant materials like corn, and biodiesel is produced from vegetable oils like soybeans. Algae is another source of oil for biodiesel. Hydroelectricity is generated from the energy in the water. The largest hydroelectric project comes from impounding water behind a large dam and releases it periodically when electricity is needed. So, the impounded water behind the dam can promote recreation, economic opportunities, but it can also have numerous impacts on the environment. Water availability in a region may be somewhat variable. And next step, we're going to talk about two examples of non dependable sources of renewable energy. They're going to be the sun and the wind. Well, the sun and the wind are dependable, so I mean non depletable.